of the most volcanically active mountain ranges on Earth. Bob Ballard is one of the few people to have seen it up close and personal.
I call it the boundary of creation, because it's along this mountain range where the Earth creates its outer skin.
Until around 40 years ago, the mid-ocean ridge was a geological conundrum. How did this range of mountains form under the sea? According to the theory of plate tectonics, the Earth's crust is made of a series of interlocking plates. When two plates push together, they can form mountain ranges. But at the mid-ocean ridge, the plates aren't pushing together, they're pulling apart.
When you look at mountain ranges like the Himalayas and the Andes, these are caused by plates crashing into one another. And so you can sort of imagine, yeah, that makes sense. You have two plates crash into one another and they buckle up, they'll make a mountain range. But what the mystery of the mid-ocean ridge was, how do you make a mountain range pulling apart? Didn't make sense.
So in the 1960s, geologists come up with a radical explanation. The mid-ocean ridge is like a giant blister. Molten rock from deep in the Earth's mantle wells up between the plates, oozing magma out into the sea. This magma then cools and solidifies, forming a ridge thousands of feet high. It's a neat theory, but there's a problem when it comes to testing it. The water surrounding the mid-ocean ridge should be warm, heated by the magma as it emerges from the ridge. But temperature readings taken along the ridge are much lower than the scientists expect. And if there's no heat, it could mean there's no magma and no explanation for the existence of the mid-ocean ridge. In 1977, Bob Ballard leads an expedition to try to solve the riddle. A lot rests on his mission. Signs of the missing heat would provide vital evidence to support the theory. So Ballard uses the most cutting-edge technology of the 1970s.
It was called ANGUS, which stood for Acoustically Navigated Geological Underwater Survey System. And it was basically a dope on a rope.
Angus's heavy cage protects a heat probe inside it. This probe sends temperature measurements back to the ship's bridge. Angus is also equipped with a camera to photograph the sea floor.
We don't get to see the pictures till we recover it many hours later, but we do have this one little link with it of temperature. So we have a little plot, and all of a sudden, plot, plot, bam, it jumped on us. And we said, it went through hot water. And we wrote down the time.
Is this evidence of the high temperatures they're searching for? They haul Angus back on board the support ship. Ballard and his team carefully cross-reference the measurements with the photographs. And the results are startling. The photos reveal a vent spewing out superheated water at the exact spot Ballard had recorded the heat spike. Here at last is the heat the theory predicted, evidence to support the idea that magma is welling up through the dividing plates at the mid-ocean ridge. And because heat is released through these vents, it explains why temperatures elsewhere on the ridge are lower. But the photographs reveal something else, something nobody predicted. Where the water is cool, the photographs show clean black lava. But in the hot spots, everything changes.
Lava, lava, lava. Every 12 seconds, a picture. And then as we approach the magic moment, the water got cloudy, very cloudy, and then hundreds of clams, big clams on the bottom of the ocean, and then out.
It doesn't make sense. Life shouldn't survive in these inky waters, starved of all sunlight. To get a better look, Ballard returns to the mid-ocean ridge in a custom-built research submersible.
We had been told in our textbooks that the sun cannot reach the abyssal depths of the mid-ocean ridge, so you can't have photosynthesis. In the absence of photosynthesis, you can't have plants. In the absence of plants, you can't have much life. And yet, here was another system.
Ballard and his mystified team collect samples and contact biologists back on shore.
They said, okay, we've got this big worm, 8 feet long. What are we supposed to do with it? And they said, no, what? You've got an, and we tried. They couldn't believe what we were describing to them. And we said, well, you'll have to believe it because it's right here. I have it in my hands.
Ballard's claims stun the biologists. They ask him to preserve the specimens.
And they said, well, put it in formaldehyde. And we said, well, we're geologists. We don't carry formaldehyde. Well, do you have any vodka? And we said, oh, that's getting, now you're getting personal, because, you're out at sea for a long, long time. You bring a little liquor with you. We had to use our liquor to preserve these creatures, so we didn't collect as many as we probably should.
Ballard's expedition had solved one geological mystery, only to stumble upon a new biological one. The discovery flies in the face of the previous scientific assumption that without sunlight, there can be no life. Scientists considered photosynthesis the basis for all life on Earth. But here is life without light. So how do these strange organisms exist in the dark ocean? On a mission to investigate the mid-ocean ridge, explorer Bob Ballard and his team discover a whole new ecosystem. Here at 8,500 feet down, life thrives in the dark depths.
We came in on this incredible zoo of creatures, exotic creatures, but mostly what was so impressive was the fresh lava was so covered with marine life, you couldn't see the lava. This is not supposed to happen.